Welcome back, everyone. We're in chapter 15 on oxidation reduction. And in this section, we are talking about balancing oxidation reduction reactions using half reactions. I would call this section very hard. It is like balancing equations, which was hard when you did it at first. And it's also dealing with oxidation reduction. And it's somewhat reminiscent of the net ionic equations that we did when we broke everything into charges and then canceled out the charges that were on both sides, or the spectator ions that were on both sides. So this is one that I would say needs a lot of practice, and I hope that we have time in class to practice this adequately. But I'll try my very best. Please take notes and please try to pay attention to this. This has to somehow get into your brain. Okay? All right, so I'm only going to give 4 slides today, and that's just going to be one example problem. And then from this example problem, we'll try to see how that you're going to do it, and then we'll practice again later, okay? So here's the problem I'm going to use. Balance the following reaction in acidic solution. Okay, so if you remember an acidic solution, you're going to have some kind of, like if it's acid, it'll break apart and you're going to have, it dissociates. And so you're going to have things floating around in the water. And that's what this aqueous means, okay? In the case of iodine, you're going to have anions, iodine anions, and sulfate anions. And you're going to end up at the end with iodine, which is like this, only that the only difference is that it has given away an electron and become uh, an element again. It becomes the iodine element. So this was part of a compound, and it's broken apart because it's in the water. It's broken apart in the water. Electrons are going to be stolen, and then once it's stolen, it's going to become an element. Likewise, the sulfate, this is a charge. Now remember, this -2 is not for the sulfur, it's for this entire thing. And somehow, whatever charge this sulfur happens to have, eventually is going to get rid of electrons. It's going to give it to the iodine and then become sulfur, where it has a 0 charge. So if you remember, you need to know which one has gone up and which one has gone down. So what's your guess? This one was negative, so that means it started off at -1. What is this? This is an element, so this is now 0. So this has gone up from -1 to 0. So this is the one that's oxidized. So a half reaction, I'm only interested in part of the reaction that goes up. What goes from low to high? And I'm going to write it in one side. So I'm going to write it up here. This one went from -1 to 0. So this is the oxidized half of this reaction. What about this guy? Okay, this one went from it being some kind of a charge. This was negative. The whole thing was negative, to where this now becomes neutral. Well, you know that if this one went up, this one went down. Okay, because let's see what this sulfur was. I know that oxygen's -2. 4 times -2 is -8. So this side is -8. And if this were neutral, this sulfur would be +8. But this is not +8. It's not neutral. It's -2. The whole thing is an ion. So that means what? -8 equals -2. And we'll see that this is +6. So +6, and this is 0 because this is just elemental sulfur. So this went down from a +6 to a 0. Okay, so this is the oxidized, and this is the reduced. So in order to figure out all the parts, everything, all where the electron is, and all the different ions that are involved, this is the easiest way. And even though it looks hard, it's the easiest way to figure it out. Okay? So we'll just do it in a very systematic way. First, I'm going to write it in 2 parts. I'm going to do the oxidized, and then I'm going to do the reduced. So I negative went up to I2, which is neutral. So I'm going to write that here. I negative goes to I neutral. So this is -1 up to 0. The reduced 1 second, SO4 -2 goes up to sulfur, okay, S. So this is the reduced. So you start with an oxidized, reduced. Okay, now don't pay any attention to oxygen or hydrogen. Do that last. Anything else that can be balanced, do it. Okay, so I see here that there's 2 iodines on this side, but there's only 1 iodine on this side, so I'm going to balance it. So I'm going to multiply this side by 2 so that they both have 2 iodines. This is already balanced. I've got 1 sulfur and 1 sulfur, so I'm okay with that. So balance everything that's not oxygen and hydrogen. Okay. The next thing you're going to do is you're going to balance oxygen. So oxygen, the way you balance an oxygen is if you need oxygens on the other side to balance something, you add waters equal to that amount of oxygen. So let's look at the sulfur. SO4. How many waters do I need? I've got 4 oxygens on this side, so I need 4 oxygens on this side. So how many waters will give me 4 oxygens? Water is H2O, so I need 4 waters in order to give me 4 oxygens. I'm going to add on the right 4 H2O. Okay, so I'm going to have SO4 -2 yields S plus 4 H2O. So you see it here. Now the problem with that is that by adding H2O, I added something I didn't have, and that was hydrogens. So in order to balance on the other side, I have to add hydrogen ions, protons. So I've got my oxygens are balanced, so I have 4 and 4. My sulfurs are balanced, I've got S and S. But now I've got 2 times 4, I've got 8 protons on this side. So I'm going to come over to the other side and add 8 protons to balance it. Okay, so that's step 2. So let's see what I do. I separate it. Which one's oxidized? Write it down left and right. Which one's reduced? Left and right. Write it down. Then I balance anything that I can that's not hydrogen or oxygen. Then I do the oxygen by adding water. So I needed some oxygen on this side. I needed 4 of them, so I added 4 water molecules. Then to balance it, I had to add what was the equivalent of the hydrogens in the water. So if I had 4 waters, that's 8 hydrogens because there's 2 waters in each. So I had to add 8 hydrogen or 8 protons on the other ones. So far so good. Going further, okay, now I need to know what my charges were. Okay, so what did I lose? I went up from -1 to 0. So this one went up 1, but I have 2 of these. I have 2 molecules or 2 ions, so each of them went up 1. That means that it gained 2 electrons. So I'm going to put the 2 electrons on the side with the more positive charge. Okay, because the electrons, it went up, and so it's showing me that the electrons were stolen, and that's what's on this side. I've got the positive side, and it balances with the negative. So I've got 2 negatives on this side, so I end up with needing 2 negatives on this side to balance it. So whatever side is more positive, add the electrons that were stolen on that side, on the more positive side. So over here, which one's more positive? Okay, I've got -2 and +8, so this is +6 on the left. Here I've got 1 and 4, so this is +5 on the right. So 6 is more positive, so I'm going to add 6 electrons on the left. Okay, so why? Because what happened? It went 6 electrons were stolen. Okay, but 6 electrons were stolen away. So I'm going to put 6 electrons on the side with the more positive charge. Okay. The next step is to reconcile these two. So I've got 2 sides, and I want them to be equal to each other because whatever is lost on one side is gained on the other. So I say, okay, what is the common multiple between 2 and 6? Okay, what number does both of the numbers go into? 2 goes into 6 and 6 goes into 6. So what number do I multiply 2 by to give you 6? So do you see I'm only looking at the electrons? What number do I multiply 2 by to give you 6? 3. What number do I multiply 6 by to give you 6? 1. So I'm going to multiply every part of both sides by that factor. So on the top, I've got 1 on the left and 2 on the right. I multiply all of these by 3. So I'm going to do 2 times 3, okay, is 6i negative 1. I'm going to do 3i negative I to the second, or I sub 2, and I'm going to do 3 times 2 is 6 electrons. So on the oxidized side, I end up with 6i negative yields 3i2 plus 6 electrons. On the bottom, I didn't have to do anything because it was already 6. Because I'm trying to get them equal to each other. Okay? Equal to each other. So that's the next step. Once I have them, I simply add both sides together. I have the 6i plus the 6 electrons. Say this was the oxidized one. This is the reduced one. And I add left to left, right to right. What you're going to see is since that I made them equal, I made the electrons equal on both sides, they will cancel out. And everything else is in my balanced equation. So I have 6i, the 6 electrons will cancel because they're on both sides. I have the 8 protons, I have the SO4, the sulfate, and the 6 iodine ions, all on this side. On this side, I have 3 iodine molecules. I have 6 electrons, which will cancel. I have 1 sulfur atom and 4 water molecules on this side. So here is the entire, this is the entire equation that I derived from both sides. I did them individually and then added them up together. Okay, so you simply check them to see if you've got the same number on both sides. So the atoms, I've got 8 H's. Over here, 2 times 4, I've got 8 H's. Here I've got 1 sulfur. Over here I've got 1 sulfur. Here I've got 4 oxygens. Over here I've got 4 oxygens. And here I have 6 iodines. And over here, 3 times 2, I've got 6 iodines. And then you check the charges. I've got 8 times positive 1 because hydrogen was positive 1. I have 1, negative 2. I have 6 negative 1s, and all that equals up to 0. That's how I can tell that at the end, if everything equals 0, then I have gone from, I've only transferred electrons. One went to one place and went up by that same amount, and the other one dropped. And this is hard. I call this hard. So we'll do lots of examples in class, and you can even check other YouTube videos. I think this would be really good to investigate on your own. Okay, I'll see you in class.